Hello guys, welcome back to Maths on African Motives. Still working on engineering science and for working on revisions. We have got questions that we're going to be focusing on projectiles. So we've got typical questions that we are going to work with, but before that, we just have to work with the introduction part and see how are we actually supposed to attempt such typical questions of this nature. If you had to check on our projectile concept, we simply need to understand that let's say we are given our projectile at an angle of theta. We are going to have two components which are going to affect our angle that is at theta in this case, having our initial velocity. All right, so here having our initial velocity measured in meters per second and the angle theta affecting our projectile in this case. We are going to see that this is horizontal, this is our vertical component. As just like our components from our engineering science N3, we talked of components, horizontal component, the one that uses the cosine of theta, the vertical component, the one that uses the sine of theta from the opposite over hypotenuse concept of a right angle triangle from our N3. So what does it mean here? It simply means that we have got the horizontal velocity, like I said. So this is going to be our horizontal velocity. All right, so we are going to have our horizontal velocity, which can also be from displacement again. So we are going to have and displacement. All right, so and displacement in this case. So that is going to affect the displacement and the velocity at the same time. The same thing is going to happen on this side, whereby, all right, so this, let us just finish on this part here. Let us just finish. So this can be given as Vx. Like I said, the horizontal uses the cos of theta. So it's going to be U cos theta. So this one is referred to as U cos theta. That is our Vx in this case, which represents the velocity. We shall talk of displacement later on. All right, then on the other hand, whereby we are having our vertical part, all right, so here we are going to have vertical velocity and displacement again. So we are going to have our vertical, there is R there. So we have got our vertical velocity and displacement, which is the height in this case, all right? So this can be our height, which now is given as Vy. So that would be Vy is equal to U. Like I said, vertical uses the sine of theta, so it's gonna be sine of theta like this, all right? So that is for the vertical part. All right, so I'm going to explain these now in detail. Let us have these two in detail. We are going to separate between the vertical and the horizontal. All right, let me just hope we are going to have something to write here. I can just reduce a little bit so that you can have some notes before we attempt those typical questions. So we have the vertical and also the horizontal. The horizontal is sometimes referred to as the range, all right? So on this other hand, we are going to be talking of the horizontal. So the horizontal sometimes is referred to as the range. So this is given as the range in this case. Whenever they talk about the range, you are simply talking of the horizontal, all right? So under the vertical component, we listed that already there is velocity, this Vy that we said Vy is equal to the U sine of theta, where U is our initial velocity in meters per second in this case. So having wherever we are going to write a velocity, meaning to say we can be talking of the vertical displacement, the velocity that we are going to be talking about with, or the velocity that we are going to use there is the one for the vertical is one for the vertical component, all right? So what I'm saying is that we can have the vertical displacement in this case. So the vertical displacement is simply taken as SV or SY from the vertical. This is vertical, you can write as S vertical or SY in this case. All right, remember that S is equivalent to UT plus half gt squared. But this u that we are talking about is the one of the vertical component. We are talking about this u of the vertical component, the one that we said v. So we are going to write our formula as vy in this case times t plus half of gt squared. In place of the acceleration, we use the g in this case. So this is referred to as the maximum height, whereby they will be talking of the maximum. We are talking about the height at that corresponding element. All right. So instead of having this part as displacement, now we have to calculate y and so forth using this u that we see here, the initial velocity. So you can use this at once. So using u, which is our initial velocity in this case, our initial velocity, the one that we are given, the initial velocity, we can calculate the value of our maximum, which is h max. We're going to have this as h max, which is the maximum height now. It is equal to u squared over 2g sine squared theta in this case. So sine squared theta simply means sine theta like this squared. So instead of calculating a lot of things, if you know this formula, it is going to be an advantage because you just need to substitute your information direct on the formula the way that you are given. All right. But now we are saying at this maximum height that we are talking about, instead, if you wanted to use this velocity that we are, the displacement whereby we talked about the initial and also finding Vy, which is the vertical component, it means we are going to have now this written as at maximum height, we are going to have this as h max is equal to v squared minus the initial velocity, which is Vy squared, everything over 2g. But this one is the vertical component, which is the u sine theta, this one. So meaning to say here, we are simply talking to u sine theta. So it's going to be u sine theta squared. All right. Then at the maximum height, what you also need to know is that at the maximum height, it follows that t is equal to v minus vy over g in this case. All right. So this is what happens at the maximum height, that t is equal to v, whereby v is representing the final velocity, and this vy here, vy, is the one that we are representing here as u sine theta, our initial part. All right. So that is what you need to know on your vertical part if you're dealing with the vertical. All right, let's talk about the horizontal before we attempt our questions. I think I've talked a lot, so let me finish up before we attempt our questions. On the horizontal, whereby I say this, we are talking about the range. We discussed one thing, that Vx is equal to u cos theta. We are using the cosine of theta. And it also follows that the horizontal displacement, which is the range in this case, the range which is given as SH is equal to u squared sine 2 theta, this time sine 2 theta over g. So this formula is very, very easier to use because you are simply substituting this u, our initial velocity, the way it was before. All right. But if we are to calculate this same component, we can actually use the same SH, which is equal to Vx times the time. All right, but in this case, we are supposed to calculate Vx, and I said Vx is u cos theta, this one. So it's going to be SH is equal to u cos theta times the time. That is what you're going to do. But always when you are given by this component, the time is always to be multiplied by 2 so that you obtain the exact value there. And this time at maximum height, in this case, whenever you'll be talking of the maximum height or the maximum range or the maximum distance that is being taken, this time our theta is supposed to be taken at 45 degrees. All right, our theta is supposed to be taken at 45 degrees. So I think with this information, or with these formulas, we can be able to attempt 1 or 2 questions. Others I'm going to explain as we are attempting questions so that we'll see. But like I said, they are best formulas to use that save us a lot of time, because remember, exam is also about the time that you are given. So you're given that a bullet is fired at an angle of 33 degrees to the horizontal at a velocity of 110. So we are having a bullet being fired at a certain angle of 33 degrees in this case. All right, so we are going to have something of this nature, whereby the angle here is 33 degrees. Our initial velocity being at 410 meters per second. Then the question on 1.31, calculate the maximum height. So instead here we talked about calculating the maximum height in 2 different ways. To say the maximum height reached here can be calculated from this H max, which is from this one, this formula, or we can calculate our H max from this formula. So I'm just going to explain, but you see that at the end, the first formula is the easiest because you simply have to substitute your values as they are. So I said from the first formula, our maximum height can be taken from the formula of u squared over 2g by sine squared theta, of which we have got everything. The u here is your initial velocity of 410. So meaning to say you are going to have u squared, which is 410 squared over 2 times g, our gravitational acceleration of 9,8, times sine theta squared, means the sine of the angle, sine 33 degrees, everything squared like this from your calculator. You're going to use this as a squared. All right, so if you have to simplify properly, you're going to obtain 2,544,071 in meters, of which you can write in kilometers if you want. All right, but I said from the other formulas that if we are to calculate this H max at the same time, it can be given as H max is given as v squared minus vy squared over 2g in this case. All right, I want us to concentrate on this formula. This here is our final velocity, and whenever we are talking about a vertical, at the final velocity, we are going to have our v being equal to 0 meters per second. And this Vy is the one that I explained that it is equal to the u sine of theta. So meaning to say we have to calculate our Vy from these components that we are given. All right, so let us just calculate these ones aside, then we substitute into the formula. So Vy is equal to u sine theta, which is u 410 sine of theta, which is sine 33 degrees. So there you are going to obtain something like 202.302 in meters per second. We are talking about the velocity there. But if we are talking about the final velocity on a projectile concept, the final velocity will be at 0. There will be no movement at the final velocity, meaning to say our v, which is the final velocity, this one will be at 0. So that means we can be able to calculate our H max. So our H max is equal to v squared. What is our v squared? The final velocity, that is 0 squared, minus vy, this one that we got, which is 223,302. All right, squared again. Everything over 2 times the gravitational acceleration, which is taken as a negative because you are opposing this object to be going down. It's going up and you're opposing it to be going down. So it's going to be taken as a negative. So our H max is going to give us something like 2,544,071, something like that in meters again. So that is the idea of this typical question. If you are to consider this, you are supposed to obtain the exact or the same thing from this part. All right, let us see the other part of the question. Now we are given the horizontal displacement. Take note, horizontal maximum height. We are talking about going up. The horizontal displacement, we are now talking of the SH in this case. All right, we are in the horizontal in this case. And I said in the horizontal, what is it that we want? SH is equal to this, or we can use SH, which is equal to this one. So let's try the first formula, then we compare with the second one. All right, so this is what we're gonna have. All right, so we are talking about the horizontal, in this case 1.32. So we are talking about SH, where we said SH is equal to U squared sine 2 theta over 2G. So what over G in this case? So what you need to know is that the U is your initial velocity as it is, and our initial velocity given there was equivalent to what if we are to check. All right, so I want us to check our initial velocity, the one that we are given. All right, so if we are to check here, our initial velocity, that is the 410. So we are going to have 410. Okay, so that is 410 squared times sine 2 theta. Take note, it's sine 2 times theta. Remember, our angle here is 33. So it's going to be 33 degrees like this over G. This time your G, you use as it is 9,8. So we are going to have our SH from there as a positive. So this, if you multiply 2 times 33, is going to give us 66 degrees. So you can just use your calculator direct. You're going to obtain 15670, 101, and so on. So in meters in this case. All right, so that is our SH, which is the horizontal displacement. But we also said we can have this horizontal displacement from the second formula, where SH is equal to U cos theta times time from the Vx, this one. So we're going to use U cos theta times what? U cos theta times the time which is at t, in this case, this one. So meaning to say, we can simply substitute everything on our formula in this case to say our SH is going to be U cos theta times 2t, because we said the time there is to be multiplied by 2. So we could have calculated our SH as U cos theta times 2 times time like this, or let us just prefer it this way so that you don't confuse. The actual formula is supposed to be like this, but everything that you're going to have is multiplied by what? Is multiplied by 2. So meaning to say you are going to have the same thing. Our U, remember our U is 410, so it's going to be 410 cosine of the angle 33 degrees times the time in this case, all right, of which we need the time in this case, all right. All right, so we are going to need the time frame that was taken. And where are we going to obtain this time from? All right, I said at this SH, our time is given as V minus Vy over G in this case, if you still remember from this formula here. We have our time. Okay, here our time. Where is that formula? All right, did I list this formula before? All right, I listed it here, that at maximum height, we are going to have V minus Vy over G, meaning to say we are going to need the Vy that we calculated before, of which we know our Vy, we calculated that one, it was here, Vy, this one, 223,30. This is the one that we are referring as Vy. That's it at the for the time, for us to have this time. So you see, this one is complicated. We've got a lot of things to consider. So instead of doing this, guys, use the first formula, okay? So I said the V there is going to be at 0. So it's 0 minus V, which is Vy, we say it is 223,302 over negative 9,8. So there we are going to obtain our time being 22,786 seconds. All right. So with this time now, this is the one that you're going to consider here. We're going to multiply by time, which is 22,786 times 2. There we are going to obtain our SH, which is going to be something like 15670, 160 in meters. All right. So if you check here, there's a lot of things that you need to consider. But on the first formula, if you are to know this formula, is direct because there's nothing that you are changing or finding. You're just substituting exactly the initial velocity and the angle and the gravitational acceleration only. These are the only things that you actually need. So I prefer the first one in my calculations very, very much. Okay, anyways, let us check the other part of our questions and see how can they give us same typical questions. This one, we are given that an object is being taken at all right, I think it's okay. This one is at 270. We are given that our object is taken at an angle of all right, we're not given the angle here, but we are given that an object is projected at such that an angle that the range, remember the range that is the horizontal in this case. So they are saying the horizontal displacement is 3 times the maximum height reached. All right. Remember horizontal, our horizontal displacement, which is the range. Our horizontal displacement is the range. So they are saying the range is equal to 3 times the maximum height. So this is 3 times the maximum height, which is h max. That is what we are given there. And the question says the initial velocity of the object is 270 meters per second. Calculate the angle that the object is being projected. So they want us to calculate the angle at which this object is being projected. All right. Remember, what do we know about these two? What is it that we know about these two? We talked about the range before, and I said the range is our horizontal displacement, which you can write it as u squared. You see those formulas now, how useful they are. U squared sine 2 theta over g. This is what we know. It is equal to 3 times the maximum height. We said our maximum height is given as u squared over 2g sine squared theta. That is what we have from those formulas. So if we are to take here, there is no need for us to even apply the initial velocity here, because our question is to calculate the angle. So if we are to check, if we are to multiply, okay, let us just multiply by 3 and see what is happening here. We are going to have u squared over g. This is same as u squared over g sine 2 theta, which is equal to 3 times this part is same as 3 over 1. This is over 1, so it's 3 times 1, which is 3 u squared over 1 times 2g, which is 2g sine squared theta. This question, you're supposed to be careful. The u, you can substitute that part, but as you can see that this one, u squared over g and u squared over g are the same. So we can divide by this. So it means this one is going to cancel. So there's no need for us to even substitute that value. So we are left with this part now, sine 2 theta on the left side. So we are left with sine 2 theta being equal to, here we are left with 3 over 2 sine squared theta. So this is going to give us 3 over 2 sine squared theta. So what are you going to do from this part? As we can see that this is no longer about engineering science. This type of a question is no longer about science. It's now you and your mathematical skills. How can you calculate the angle theta from this given equation, from our trig equations? All right. Sine squared means there are 2 of them. And we know that here from our identities, sine 2 theta, from sine 2 theta, all right, we are going to have 2 sine theta cosine of theta, all right, from our double angle identities in mathematics. So meaning to say this was going to give us 2 sine of theta cosine of theta, which is equal to 3 over 2 sine squared theta, of which sine squared theta, it means there are 2 of them here. There are 2 of them. It's like sine theta times sine theta like this. There are 2 of them. So meaning to say here we can cancel, as you can see, is sine theta here. So you can cancel with 1 sine theta. All right. And we can even cross multiply at this stage. We can even cross multiply. 2 is going to multiply both. This is the same as over 1. So it's 2 times 2 like this. So 2 times 2 here, we are going to obtain 4. So it's going to be 4 cos theta is equal to 1 times 3 sine theta. This is going to be 3 sine theta. All right, we are still to find theta and we are still to apply our mathematical skills. We know that where there is cos and sine, we can formulate tan from there, because tan is equal to the sine of theta over the cosine of theta. So in order for us to obtain sine over cos, we have to divide by cos so that it will be sine over cos. So we can divide by cos both sides, by cosine both sides. So that will be 4 is equal to 3, the sine of theta. All right. So here we are now having the sine of theta, cos of theta over cos of theta, which we said it gives us what? Tan. So it's now 3 tan theta. So to find tan, we can divide by 3 so that we remain with the tan of theta in this case. So that means the tan of theta was going to give us 4/3. And this we know, guys, to find theta, it will be arctan on the other hand from your calculator. So theta is going to be the arctan of 4/3, which is simply shift tan on your calculator. Okay, let me just save our calculator here and see what I'm trying to say. So from this, our calculator here, we are saying we are going to have shift tan, as we can see, tan here to the power of -1, 4/3. All right, that's 4/3, which is going to give us 53.130 and so on. So that's 53,13. All right, so we are going to have our theta as 53,13 degrees. All right, so that was the way that we could have used to calculate the angle of the projectile. So it's not always that you are going to be given the angle and you just calculate horizontal displacement, vertical displacement, maximum height. No, they will also need you to calculate the angle, whereby you need to know the relationship between what you are given from that concept that here we are given that the range, which is our horizontal displacement, is 3 times the maximum height. And we are simply talking about this is our range and this is our height. But this height is being multiplied is 3 times h max. So that is why we have to multiply the maximum height. Formulate an equation, solve for theta using your mathematical skills. That is the idea there. All right, so let us check another part of our questions that we have here, which is we are given that on this question, Bradley kicks a soccer ball at an angle of 32 degrees. The ball has a starting velocity of 23.5 meters per second. All right, so we are given that Bradley had to kick a ball at an angle of what? 32 degrees. So this is what we're gonna have at an angle of 32 degrees, having an initial velocity of 23.5 meters per second. All right, so from there we are asked to calculate the height that the ball will reach, the height, which means we're talking about the vertical one, the maximum height in this case. All right, so that's 2.21. Here I'm just gonna use the first formula that I listed. I think it's easier, guys. So h max is, we said it is equal to u squared over 2g times sine squared theta. But I gave you the other formulas, guys, so that you can also prove to see that this is one and the same thing. So I wanted to prove, but here I'm going to use this one, which is easier and best for us because there's nothing that you are changing. You just substitute u is your initial u as it is 23.5 squared over 2 times the gravitational acceleration of 9 squared times, only you need to know that sine squared theta means the sine of the angle, sine 32 degrees, then you square everything like this. That is what you need to understand. So meaning to say, on your calculator, you are going to have something like this. On our calculator, we're going to present a fraction here. That's 23.5 squared over, that's over 2 times 9.8. All right, that's 9.8 in this case here times sine 32. You open a bracket like this. So that's sine 32 degrees. There's a bracket for sine 32, close it. You close the first bracket, then you square everything like this. All right, so that will be 7.912. So we are going to obtain, in this case, 7.912 in meters. So that is the idea of the question in this case. So you have to be very, very careful how these questions are given. Then the other part of the question now is asking us to calculate the time it will take for the ball to reach the highest point. All right, remember on the formulas that I listed, I said at the maximum height, we can obtain the time there. At the maximum height, time is equal to V minus Vy over G, whereby V is the final velocity, which is taken at 0 meters per second. And this Vy is equal to u sine theta, if you still remember, and our G is taken as a negative. So that means in this case, we have to find an expression for Vy, but we know that Vy is u sine theta. So we can just even substitute as it is. So T is going to be 0. In this case, let us write as V minus Vy, which is u sine theta in this case in place of Vy, all right, over G. So let us substitute. Remember, we have got everything here. So our T is going to be the maximum value at 0 at its maximum. The time will the velocity there will be at 0. There will be no movement, all right. So here we've got all right, so what I'm simply saying here is that we are going to have our T as V minus Vy over G in this case. So as we stated that V is going to be 0 meters per second, and our Vy is simply taken from the u sine of theta. So meaning to say that is the one that you're going to substitute here. So meaning to say our T is going to be 0 minus, in place of this Vy, we are going to substitute now u sine theta, of which we have our u, our initial velocity there, which was 23.5 sine of theta, which is 32 degrees. All right, then everything over the G being taken as a negative. So you're supposed to take this as a negative, which is negative 9.8. So that is going to give us the time, which is going to be 1.271 in seconds. All right. So these are the typical questions on projectiles that you're going to have. But mostly they will give you the angles and so forth. These are the typical questions mostly that you'll be given, where you are given the angle, and all you need is to calculate the requirements like the maximum height and so forth. But sometimes they might even ask you to calculate the angle, just like the question that we had before. So let us use this in our preparation for the exams which are ahead.